Hello Internet, hello out there. In today's video I show the conversion of my folding workbench into a router table for my Triton router. In addition, I will show some 3D printed parts that I used in combination with my router table build. Some of them designed by me, some picked up from the internet. And related to this, I will present some basic slicer settings that I use to generate strong 3D printed parts to be used in the workshop. Therefore, I think this video has a lot to offer. I do not need my router table all the time, so I was looking for a new solution. With the rebuild, I get a space saving and a mobile solution. I have to admit, the rebuild is a bit of a quick hack, but I was in the middle of a project and needed a quick working solution. I made a drawing and a 3D printed template of my router base. I used this for building templates or fixtures in connection with my router. I also used this as a starting point to position the cutout for the rebuild of my workbench. For the rebuild, I use my Bosch PWB 600 workbench as an example, but there are many alternatives out there from brands like Black & Decker, Grizzly and many other more, as well as NoName variants. Maybe you already have such a workbench, or you can get a used one for a reasonable price. My model is sometimes available as a used version for around about 50 to 60 euros. You can find examples with a simple search in Google using the keyword folding workbench. My first approach was to unscrew one of the cover blades and replace it with a new one. Unfortunately, due to the construction, this was too time consuming. To immediately position and center the router table if it is mounted on the workbench, I added additional pieces of plywood to position the router table. For this rebuild, I used an existing router tabletop from a previous project. I add a link here and in the description to the video, which shows how I integrated the router table insert and the router into the table in detail. The tabletop is out of melamine coated plywood. It's 21 mm thick. I bought this board from the leftover box of my local hardware store for a few euros. These boards are very suitable for this use because they have a very smooth surface and do not warp easily, especially when exposed to moisture. In my case, I have embedded the base of the router into the milling table. This is quite a bit more complex, but you get a few millimeters more milling depth. The plywood board is moisture resistant and very stable. Therefore, I decided to simply cut out the necessary space for my router. The additional plywood pieces also serve as counter brackets when I crank the workbench. Furthermore, I took care to install the table at the right angle and parallel to the existing contours of the workbench. My router is a Triton TRA001, a very heavy and strong router which is perfect for stationary use in a router table. I use or rather experiment with 3D printed components and have made very good experience with it so far. But more about this later in the video. It is important to make sure that the cranks can still be turned to close the workbench. In my case, the cranks go a little bit above the top edge of the table. I solved this by opening the workbench table to the maximum and fitting the plywood pieces for this setup. I only need a half turn to clamp the milling table firmly. And another advantage is that I also keep the cutout as small as possible in order not to sabotage the other functions of the workbench. To make sure that the top of the milling insert is flush to the upper edge of the milling table, I glued some thin adhesive tape under the insert to adjust the height. Later I decided to make the cutout a little bit bigger because it makes the setup of the table much easier and faster. Finally, I attached an emergency switch to the router table. Normally, it should be mounted on the front side of the machine, but I usually stand on the right side and feed the workpiece to the machine. Therefore, I mounted it on the right side. Here is it also fast and easy to reach. The installation takes about 1 to 3 hours of work, depending on how you want to connect the router to the blade of the milling table. In my case, I have embedded the base of the router into the milling table. This is quite a bit more complex, but you get a few millimeters more milling depth. A big advantage of the Triton router is that it has this built-in lift function. You can raise the shaft with a crank and it locks in the highest position. So you can easily change the milling tool and then bring it back into position. I use various 3D printed components in connection with the router table. Among others, the router table insert, the mounting brackets for the router fence and many more, as we will see later. Using 3D printed parts allows me to experiment with different solutions and settings and at very less costs. The milling insert is not quite perfect yet. I would like to equip the inner part with magnets, so you can easily change the inner part using different sizes of the opening of the insert to fit the size of the milling tool. I also designed some new 3D printed brackets for the milling fence to make the fixing of the milling fence faster and easier. Without going into much detail, here are some basic parameters for 3D printing with PLA, PLA Plus or PETG. The goal is to get the strongest possible parts for the use in the workshop. First of all, I check what the filament manufacturer recommends. For new material it might be necessary to print a heat tower and calibrate the printing temperature on the outcome of the heat tower test. What kind of filament will I choose? I normally go with PLA filament. It's usable for many parts. So for stronger parts I use PLA Plus or PETG and only in exceptional cases ABS. Third, I choose 5% to 10% higher print temperature to achieve a good layer bonding. Fourth, for the wall thickness I use 3 to 4 times the size of my nozzle size. For example, for a 1.4 nozzle, I will have a wall thickness of 1.2 millimeters. Fifth, for the infill ratio I use a value of more than 35%. And for the infill pattern I use honeycomb or better cubic or gyroid. Sixth, I choose the layer height depending on the level of detail, usually 0.2 to 0.3 millimeters. There is a lot more to consider, but I will show this in one of the following videos and share my experiences with you. Then I picked a new star knob design for M8 screws from Thingiverse. I will put the link into the video description below. The interesting thing about this solution is that the nut in the star knob is secured by an additional 3D printed part with a snap-in mechanism and does not need to be glued in. This knob has a very nice design and I printed it in PLA, but it's very stable. In order to improve the results of the work with the router table and to make the work with it safer, I added 2 additional T-nut rails to the table and downloaded and printed out a Featherboard from Thingiverse. Also here you can find the link in the description. I currently have 2 printers in operation, an Anycubic Mecha as well as an Creality CR10S4 that I use for larger workpieces. Both printers are really very good and suitable for everyday use. Unfortunately, due to an error in the feeding of the filament on the CR10S4, I got a problem with the layer binding in some places, but it was at the end of the print. Since I didn't want to do the print again, which takes around about 12 hours for one bracket, I decided to use a solution with hot glue and glue the appropriate places with the hot glue gun. So far it looks as if the solution would work fine. Finally, I would like to show once again how the converted router table has stood its ground in its first use. I think it's very good and I call this result a success. With the rebuild I have a space saving and in addition a mobile solution for the use of the router in different places. If you like the idea and you want to copy it and have questions, let me know. If I have the chance I will answer your questions. Just leave them in the comment section below. It would be great if you like the video so that it becomes a little bit more known, picked up by the YouTube algorithm. Yeah, and of course you can subscribe to my channel if you're interested in more DIY, 3D printing, design and workshop content. Yeah, what can you watch on this channel? Currently I'm working on different projects in the workshop and also in the garden. Some of them I will show on my channel, especially the topics 3D printed construction and design in combination with wood and metal. This I find very interesting and I will publish more about it in the next weeks. That's it for today. See you soon and many greetings, stay healthy and yeah, thanks for watching. Have a good time. Ciao.